Good afternoon, ma'am. So here we are doing the presentation of assignment one of advanced machine learning, and the topic name is evaluate and compute the performance of two machine learning models using statistical metrics. And next slide. These are the contents of our presentation. Next, so coming to the introduction part, in machine learning, evaluating the performance of classification models is very important to ensure they make accurate and reliable predictions. It means machine learning models need to be tested properly to make sure their predictions are both accurate and trustworthy. And next, classification metrics help us measure how well a model predicts the correct category or class for given data. So it means metrics are tools that tell us how good our model is at predicting the right class or label for each piece of data. And next, instead of depending on only on accuracy, we use multiple metrics such as precision, recall, F1 score, and ROC AUC to get a detailed understanding of model behavior. So it means accuracy alone doesn't give the full picture. Na? That's why we also use other metrics like precision, recall, F1 score, and ROC AUC to understand how the model performs in detail. And next slide. So coming to the dataset loading and pre-processing. Uh, w- uh, first, first we use the breast cancer dataset available in the sklearn datasets library. So for our project, we use the breast cancer dataset that comes built in with scikit-learn. And next, loaded the dataset using load breast cancer function from scikit-learn. So here we loaded the dataset using a simple function called load breast cancer from the scikit-learn library. And next, converted it into a pandas data frame for easier handling and visualization. It means then we convert it into the pandas data frame, which makes it easier to view, handle, and visualize the data. And next point, divided divided the data into training 80% and testing 20%, set using train test split. It means next we split the data 80% for the training the model and 20% for testing using the train test split function. And next, applied standard scalar to normalize the data before training logistical regression, since it is sensitive to feature scaling. So it means finally we use we used standard scalar to normalize the data. This step is important because logistical regression works best when all features are on the same scale. And next slide will continue by my friend Rohit.
Thank you, Shukumar. So this is the model training. This part explains how the models were created and trained on the datasets. First, there are two types. There are two models: logistic regression and random forest classifiers. So the logistic regression implemented using logistic regression from scikit-learn. The data was first scaled or normalized before training, since logistic regression is sensitive to differences in features scales. The logistic regression worked by fitting in a linear boundary between classes and calculating the probability that sample belongs to the particular class. For example, in breast cancer dataset, it estimates the probability that tumor is malignant or benign. So, random forest classifier implemented using random forest classifier from scikit-learn. It looks like there is a typo. The random forest is an assembled method, meaning it combines many decision trees to make prediction. It handles nonlinear relationships well and helps reduce overfitting by averaging results from multiple trees. Both models were successfully trained on the datasets. So next slide. Evolution matrix. After training the models, several matrices were used to check how well they perform. So the confusion matrix, the table that shows the number of correct and incorrect predictions, it helps to visualize model performance. Precision measures how many of the predicted positive were actually corrected. means high precision means fewer false positives. Recall measures how many actual positives were correctly predicted by the model. Means it high recall means fewer false negatives. F1 score, the harmonic mean of precision and recall. It means it balances both, useful when there is an uneven class distribution. ROC and AUC curve, which full form is receive operating characteristics area under curve. It measures the model's ability to the distinguish between classes. It explains higher AUC means better model performance. So next slide is explained by Rohit.
Thank you, Rohan. Here results comparison. Two models were trained and tested on the same dataset, and logistic regression as a simple linear model, and random forest is an ansible model made up of many decision tree. Here logistic regression where precision equals 0.96, where 96% is positive predictions, and recall is equal to 0.98, where it specified caught 98% of all true positives, and F1 score is 0.97, where balanced performance between precision and recall, and ROC and AUC specifies 0.99, which means almost perfect separation between classes, and random forest precision 0.998, where 98% of positive predictions were correct, and recall 0.97, where it caught 97 percentage of true positives, and F1 score of random forest is 0.98, where it balanced and slightly better overall, and ROC and AUC is equal to 0.99, where same as logistic regression. It has a distinction capability compared to logistic regression, and both models perform excellently. Here random forest slightly better than logistic regression overall. And the next slide is about conclusion, and our experiment shows that using different evaluation metrics helps us to understand how the model performs clearly, and relying only on accuracy can be misleading, and it does not show how well the model benefits and performance, and it may handles false positive, false negatives, and metrics like precision, recall, F1 score, and ROC give a more complete picture of how the model perform in different situations. And in this study, random forest was found more robust and accurate than logistic regression, mainly because it enables approaches, reduce errors, and improves generalization. Therefore, evaluating models with multiple metrics is very important to choose the best and most reliable model for real-world classification tasks. And thank you for giving this opportunity for presenting our assignment one topic. Thank you, ma'am. Arshada.
Thank you, Rohit. Now I'll be giving the quick information of the code and the output of the code by step by step. Here, import NumPy as MP. Load the Python libraries you need like NumPy, Pandas for data, a Matplotlib, CBOM for plots, and the sklearn for the dataset models, scaling, splitting, and the evaluation matrices. Datasets and target setups. Loads loads the wine dataset and the classes. Train test split. Here, train test split, which takes 80% for the data for training and 20 for testing. Stratify is equal to y. It keeps some same classes ratio in the both the sets, and the future scaling. For S standards, the scalar standardized features mean is equal to 0 and STD is equal to 0. Import for models like logistic regression and makes learning stable, and the model training. Logistic regression, a linear classifier that outputs probabilities, a random forest classifier, which assembles the decision trees, which helps to more reliable, and the prediction and the probabilities. Predict gives which gives the class levels 0 or 1 for the test data, and predict gives the predict probability for the positivity class 1 needed for the both ROC and the AUC, and the evaluation for the printed for the each model. Confusion for confusion matrix, True negative plus true negative and false positive, and false negative and true positive. True negative is actual 0 and predicted 0. False positive is actual 0 and predicted 1. And for the classification report, uh, precision, recall, and F1 score, which helps us to support both the classification report. Here, ROCA area under ROC curve higher is better and 0.5 and random chances. And for the visualization, two heat maps side by side, confusion matrix for logistic regression, and for the left and the random forest, this makes true positive and true negative, for and false negative and false positive, and easy to see here. And ROC curve plot shows trade-off between the positive true positive rate and false positive rate. The closer curve to the top left, the better. The UC value is printed in the graph, and in the next and for the next code. And for the next code, import pandas as PD, which is the library for the which helps for handling the data. Matplotlib and the Seaborn for the plotting graphs, and SKLM for loading the dataset, training model, and calculating evaluation matrices. We are using here new models here like gradient boosting classifier, which is an advanced assemble model that builds many small trees to improve accuracy. Step 2 and the helper function. A helper function for plotting. No, two helper functions are created for visualization. Plot features importance shows which features are most important for predictions, and displays the top 10 most important and as a horizontal bar chart. Plot ROC curve custom. Plot the ROC curve and shows how the well model separates the two classes, and the AUC value to is printed on the graph. And the curve closest the top left corner means better performance. And for the next function, load the breast cancer dataset. Here we use a built-in breast cancer dataset from the sklearn. X is input features and Y for target values. This is the binary classification problem predicting if a tumor is cancerous or not, and split the data. Here we will split the data into training and for in the both training and testing part, 80% for training and 24% for testing. Stratify is equal to Y ensures both sets have the same ratio of cancerous and non-cancerous samples. Training the gradient boosting model. The gradient boosting classifier n estimators is equal to 100. N estimator 100 builds the 100 small dot decision trees. Learning rate is equal to 0.1. Controls how much each tree contributes. Random state is equal to 42. Keeps result consistent. The model learns patterns between the futures and the cancer diagnosis. And make prediction. Y underscore PRED predict class labels 0 or 1. And step 7 model evaluation. We calculate key matrices to check performance, accuracy, ROC curve, and the confusion matrix. Here, accuracy helps us for making predictions where correct out of total, and ROC AUC curve. Overall ability to distinguish between classes closer to 1 is the best. Confusion matrix shows the current count of the which is correct or wrong. And the last part is visualization. Features important features where the plot are happen shows which features are most useful for the predictions like worst area, mean, texture, etc. The top bar represent the most important features. The ROC curve displays the true positive rate versus false positive rate. The orange curve represents the model, and the dotted line shows the random guessings. The larger the UC area, the better the model. We trained here the gradient boosting model and the breast cancer dataset. It achieved a higher accuracy for the both ROC and AUC, showing it an excellent and distinguish between the cancerous and non-cancerous tumor. The confusion matrix shows very few errors, and the ROC curve is the close to the top left corner, providing the strong model performance. The future important plot is helpful for the both understanding which factors are most influential and predicted breast cancer. And this is the output of our assignment. Thank you, Akshata ma'am, for giving this opportunity to present our idea. Thank you, ma'am.